Alright. So recall an isotope is an atom that has different numbers of neutrons. So, for example, isotopes of carbon. We have carbon 12, carbon 13, and carbon 14. So to put in hyphen notation, this is carbon 12, carbon 13, and carbon 14. The top number is the mass number. The bottom number is the atomic number. And then we have the symbol. So this element is carbon. We know that from the symbol, C. The number 6 on all of them refers to what? The atomic number, which is equal to the number of protons. 12, 13, and 14 refer to what?
The mass.
The mass number, not the mass.
Oh, so you have to add the number to it?
The mass number is number of protons plus number of neutrons.
So the difference.
How many protons and neutrons are in the first isotope? Carbon 12. So 6 protons. And how many neutrons? 6 neutrons. We can subtract these two numbers to get it. What about the second isotope?
6 and 6.
So 6 protons. 13 minus 6 is 7. And that tells us how many neutrons we have. And again, since these are all carbon, they're all going to have 6 protons. How many neutrons are in the third? 8. So what's the atomic number of uranium?
Let's see. 235. I don't even know what that is. Oh, okay. 92. I don't even know. It's 92.
So looking at the periodic table, we have uranium right here. Its atomic number is 92. That's how many protons it has. So 92 is the atomic number for uranium. So we get the atomic number by looking at the periodic table and from its name, uranium. The atomic number is the same as the number of protons. So we can go ahead and write that down. And we're going to assume that all of these are neutral. If it's neutral, then it has the same number of electrons as protons. So for neutral means same number of electrons as protons. So for this class, atomic number, protons, and electrons are the same. The only time the electrons differ, this is only different if it's an ion. Only changes if ion. Alright, so what is the mass number? Yes, it's 235. This is the mass number. In hyphen notation,
Okay, I thought that was the number first.
In hyphen notation, the mass number is here. This is also the mass number over here. This number at the top left is the mass number. So how many neutrons does it have?
935. Oh, no, 935 subtracted by 92.
Mm-hmm.
No, 143.
143. So we got that by taking the mass number and subtracting the number of protons, 92. So we take the mass number minus number of protons. So mass number minus atomic number gives us number of neutrons. What about this one? Uranium-238. How many neutrons does it have? 146. And what is its mass number? 238. Boron. What is the atomic number of boron? 5. How many protons does it have? How many electrons does it have? What is its mass number? 10. And how many neutrons does it have? 5. We got that by doing 10 minus 5. Boron 11. What's the atomic number?
5.
What is the mass number? What is the number of protons? What is the number of neutrons? And what is the number of electrons? Very good. Now let's do this table. This table is a little bit more complicated. The information is all partial and it's all random. So, what is the symbol for helium? Exactly. What is the atomic number for helium?
4.00.
No, that's
Yeah,
the
that's I'm talking
2.
about stupid 2.
Okay.
Okay. I am slow.
Okay.
This one.
What is the mass number?
10.84.
4. Again, this is equal to atomic number plus neutrons.
Oh, we just bounced it near it.
No. This is equal to protons plus neutrons. This is protons plus neutrons. It is this number plus this number.
So atomic number.
So 2 plus 2 gives you 4. What about the nuclear symbol? This is also sometimes called the isotropic or isotopic, isotopic symbol or isotope symbol. So it's this symbol up here. How would you write it in this symbol up here? So we put 4 on top and 2 below and the symbol HE. And how would we write the abbreviated hyphen notation? Helium, you have to write the whole word out. And we put dash mass number. You could technically use the abbreviation. I like it writing all the way out. You can write it as HE-4. HE-4 is also acceptable. But I like, never mind. This is abbreviated. HE-4 would be correct. The hyphen notation is the full name. We'll go with that. HE. Abbreviated is when you use just a symbol. If it was just hyphen notation, then it would be the full word. I forgot it said abbreviated. So what is the element that uses Ti? I don't know how many people use another one on like the previous thing, or it may have been chemistry class. They use TL, which is thallium. So what is the atomic number? Number of electrons is also 22. What is the number of neutrons? How'd you get 28? So to get number of neutrons, we take the mass number and subtract from it the number of the atomic number. So number of neutrons is equal to mass number minus atomic number. What is the nuclear symbol or isotopic symbol? 50 on top. 22 on bottom, and then we put Ti, and we get Ti 50. What is the element that goes here?
Tantalum.
Tantalum. How do you figure that out?
The atomic number.
So it gives you the atomic number, so you just look on the periodic table for 73. And what's its symbol? Ta.
Math number is 181.
And how'd you figure that out?
73 plus 108.
73 plus 108. So mass number is simply the atomic number plus this. So this 2 plus gives you the mass number. And so we put Ta, and we put 181 on top, and 73 on bottom. And in the abbreviated form, it's Ta dash, what number? 181. What is the symbol for gallium? Exactly. What is the atomic number?
31.
What is the mass number?
70.
Thomas, what would happen if you rounded that mass number? Never mind, I was looking at the wrong one. So you see in this case it does round to it, but this is not always true. I thought gallium was an exception, it's not. Copper is an exception. Copper does not have a copper 64 isotope. There is no such thing as copper 64. It means that you can't always just round these numbers to find it. Usually you can. For example, oxygen, the most common isotope of oxygen is oxygen 16. You can round this. Most common isotope of nitrogen is nitrogen 14. Most common isotope of carbon is carbon 12. Most of the time you can round this, and it's very easy to see which ones you can round. If this number is very close to a whole number, like 0.0 something, 0.0 something, or 0.999 something, you can round it. But if we look at copper, it's 0.5. It's like right in the middle. The common isotopes of copper would be copper 63, copper 65, and copper 66. There is no copper 64. So we put gallium, and then we do the mass number and the atomic number. In the abbreviated, we would again do 70, the mass number here. So, this one, what is the name of the element? What is its symbol? What is its atomic number? What is its number of electrons? What is the number of neutrons?
I just realized that they're not the same as gallium. 31, 28. So pretty much silent.
Yeah. So this means that this is not this is an ion. Again, unless I specifically tell you that it's an ion, we're going to assume it's neutral. So you're right. If you notice tantalum and gallium, they don't have the same number of protons as electrons. This means they're ions. But unless I specifically tell you, go ahead and assume that these numbers will be equal. They don't have to be, but unless you're told otherwise, just make them equal. So you weren't told about carbon, so you can go ahead and assume same number of electrons as protons. What would be the number of neutrons? 7, so 13 minus 6. And what is the mass number? 13, this is the mass number. And then in abbreviated form, it would be C-13. In full hyphen form, it would be carbon 13. What is the name of the next element?
Radium.
Symbol is Ra. What is this atomic number?
88.
Number of electrons? We'll assume it's neutral, so we weren't told otherwise. What is this number of neutrons? So 226 minus 88 is 138. Did I say?
226.
Yeah, 226, I meant, if I said it wrong. And what's the mass number?
226.
And so in abbreviated form, it'd be Ra-226. This seem easy?
Yes.
This is a little puzzle solving. You're giving random bits of information. And from this little bit of information, you actually know quite a bit of information about the atom. Just from this symbol, you know a lot. So what about this? You know the atomic number, so what atom is it?
Bismuth.
Bismuth.
Oh, bismuth. It's a mess. That's what I thought.
And its symbol is Bi. By the way, remember on iodine, capital I's should have a bar on them. Idiom, capital I's should have bars on them. Iridium, capital I's should have bar on them. This is a computer print. Computer print doesn't do it. But when you're handwriting it, make sure you put bars on them to distinguish between lowercase l and capital I. Well, you know from the periodic table, I can't tell when you're writing.
The math number is 210.
So 210. So what would be the symbol?
210, BI.
And then we do Bi
Yeah.
210. Make sense? Very easy. So that is notes for you to keep.
We got homework still. We gonna make it.
And here's the actual homework.
Okay. Man, I thought. You got it. You got my hopes up, Mr. Willis. Are these like going in the grade book for this 6 weeks or like? 6 weeks. Sorry? Yeah, 6 weeks. I'm not asking you, I'm just reading the questions.
So on this homework here, this is easier than the previous thing we did together. All it wants to know is protons, neutrons, and electrons. We will assume all are neutral. So what does that mean?
Means the neutrons and the
Protons and electrons are the exact same. And this one, you're going to, don't forget to put the hyphen notation on top. So you're going to put hyphen notation, it should match this. This square is going to be left empty, and you fill out the 2 columns on the right. On the back, fill out the 2 columns to the right. Some of them are partially done. Some of them, all you have to do is write the number. Some of them, it gives you the number, all you have to do is write the name.
Mary's model.
Sure.
So everything that proton and electron is the same thing.
So protons and electrons will be the same thing on all of them.
Yeah, because it says assume all atoms. So this is
Yeah, so I'm working on it.